Hello, 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 and welcome to the Wednesday modeling stream. I'm your streamer, Bryan Bentley. This is the modeling stream. I'm the department. For those of you who don't know me, I am the department head here at CG Spectrum. For all your modeling needs, go to cgspectrum.com/3D modeling. So while this thing is loading, I'll talk about what we're going to talk about today, what we're going to do today. So I have been, if this bad boy will load, I've been working on a forest scene here. And if I can get it to, there we go. For some reason I was zoomed in super far. So last week we were working on this forest scene and building this up. I don't know why my camera's all crazy right now. So let's go to my shot cam, and then I can go from there. So, yeah, there we go. So, let's see. Where were we? So, last week, left off, we were building some materials. We were building some vines, all that stuff. I did a little bit of fiddling between the streams. So I was playing around with some volume stuff. We may or may not get into that. I think we're going to get into that, but we're going to get into some more over like some ground-based volume. So I'm going to turn off that camera volume that I built, and I'm actually going to delete my sunlight and sky. Actually, no. Let's take my sunlight. I was trying to do like a kind of like a backlit look to everything, and we can see that if I want to render out at 1/4 resolution. Let's render that. So what I want to talk about today is I was looking at, while this renders, let's look up, I went and I was like, it didn't feel foresty enough. It just seemed like really manicured. And I was like, why does it look like this? So anytime as an artist, you're like, why does this not look as it should? Like why is this not looking natural? You should always go back to reference. So while this is coming up, I went and looked up just like overgrown forests. So let's see if I can find that. Yeah, so here we go. So I looked up these overgrown forests, and I found that in most of these forests, there's not a lot of grass. It's mostly kind of like these leafy, or at least in these forests that I'm looking at. I'm also looking for forest ground fern, but even if I just go and look up overgrown forest, it's mostly, especially stuff like this, it's mostly kind of like these leafy kind of fern plants on the ground or stuff like that. So I think I'll leave the grass in, especially like something like this. Like this is just like lots of leafy stuff. So I'm gonna do it mostly with maybe like ferns or some clovers. I have that ivy leaf that I've been using over and over again. I also have a silvermine leaf in there. So I think what I'm gonna do is I'm gonna try to make maybe like 2 different types. Definitely a ground fern, because that kind of screams overgrown forest, and then maybe something like this, like just like one stalk and some leaves coming off of it, and then I can copy and paste and package that up as pack primitive. So like I said, like I always say, I don't really know where I'm going in these streams. I just kind of feel it out, and so this is very low resolution, but this is my scene. This is what I was trying to do. I was trying to do like a kind of like a backlit look, kind of like sunset or moonlight or something like that. Like if I wanted to make this into moonlight, I would take my sunlight and I would make that just a teensy bit blue. Yeah, my sunlight, I would make that a little bit blue, just so it looks like a little bit nighttime. And then that's my environment light. I made a little bit blue. So my sunlight, I also want to make kind of blue. So then that would become something like moonlit. So now this is kind of like more like a nighttime scene, but I don't want to do that. So I'm going to go back to white. And actually, if I wanted this to be like a daytime type thing, I would take my sunlight and I would make that a little yellow. And then I would take my skylight. I would leave that at a blue. Actually, I would probably go with a little bit darker blue. Because your atmospherics are going to be like that, kind of like stormy blue color. Now, my sunlight is way over here, so I'm going to put that back to kind of like a more sane position, so that I can see what's going on. So I'm going to say, let's see. Sun, here we go. Rotation, let's say 90. See where that goes. Yeah. So that rotated it up like that. So that's almost like high noon. So let's do half of that, 45. Maybe negative 45. Where are you now? So what I'll do is I'll just drag this, start dragging it, see where it goes. There we go. Went too far. There we go. So about 160 looks to be the magic number. And then I want to rotate this around a little bit. So let's do 45 here. Maybe 60. 90. So if you want to bring out your detail, and because I know my camera angle is something like this, you want kind of like a glancing angle on this. So maybe 110. There we go. And maybe we can lift this up just a little bit. 180. 90. Yeah, I think that's good. I like that. So I'm gonna go check what this looks in my render view again, just one more time. So I've gone from daytime to nighttime, or nighttime back to daytime. Mostly I'm just using this. Eventually, hopefully, I'm gonna replace this with an HDRI image. But for now, like I'm just using this as kind of like a look div, so I can see everything and I know where everything's at. So remember, I'm rendering this at one quarter resolution because I need speed. I want to be able to get the general idea of what everything looks like before I commit to a very large render. Okay, yeah, I'm liking that. It's looking good. So just to check and see what I have so far, I'm going to turn on my short grass, my tall grass, my vine curves, my vine leaves, and I don't need my tree gen. It's going to go over here because that's kind of like generator stuff. And my tree's already on, so let's see what that looks like. Is taking just a little bit to, you can see it's actually building the scene. And once that's built, I should be able to, yeah, there we go. So that's everything in the scene. Cool. So overall, this almost looks like almost like an 8-bit like old school video game right now. But so we have everything in the scene, everything's working, nothing's broken between the streams, so that's good. So I'm gonna stop this. I'm gonna move on. So the first thing I think I want to do is I'm gonna bring my render view. I'm gonna bring that back up to half because I can't really see much detail that's going on right here. I can just kind of get the overall gist that everything is working. So I think what I'm going to do is I'm going to make my grass much shorter and much smaller. And then I'm going to add in more of those leafy kind of fern type objects. So we're gonna. So today I want to go over how to you can quickly make plants. I think I've gone over this before with the trace node, or we can do it with. I can try to do it with all curves. So just curves and using a little bit of normal data and a little bit of width data, just like we did with the grass. We can make should be able to make like a pretty good looking fern. Like it won't be photorealistic, but there'll be so many of them, and I'm thinking this is going to be a little bit of a darker scene with some fog, maybe some fireflies. It should get the job done. So we'll do both of those. Okay. So first things first. For now, what I'm going to do is I'm going to let's hide my trees overall. Now I want those trees to I want them to always be renderable. So in my mantra node, what I'll do is I'll put them in my. I always want this stuff to be renderable, but I don't want it to take up like kind of like drawing compute cycles while I'm working on stuff. So I know I have my trees. I like my vine leaves. I like my vine curves. I like. So I'm actually going to just turn those off. And even my my tall grass doesn't really take that much, and like the standing stones allows me to see where things are going to go. But this is very heavy to compute in the viewport, but I still want to render it. So what I'll do is I'll go back to my render view, and I'll grab that mantra, and I will say force objects. So I'm just going to grab all these guys and just drag them into force objects. So no matter whether they're on or off in my viewport, they will always be rendered. Okay, I believe that, and if I look at the help, objects in this parameter are added to the IFD regardless of state of their display. Objects can only be added to the IFD once, right? So this IFD. So the other thing I can do is I can say, all right, exclude objects. I can say no matter what, don't render this stuff. Okay, so let's close that, and let's do. So remember, over in scene view, those things aren't on. If I go to my render view, let's just scoot this over so it's like right next to that. If I hit render, those things should still stay on. And let's just render just a little subset of this, just so I can see what's happening. Yep, great. So my leaves, my vines, and my trees are all rendering even though they're turned off in the object view. So a little optimization there for you. Okay, so let's look at ferns and how we can build ferns. So once again, I'm going to go and look at some, I'm going to go to textures.com, it's my favorite place to go for this stream. They should be paying me, but they don't. So there you go. It's a great resource. So I'm going to go to, let's see. I think I already downloaded one, but let's do scan atlases, and let's just look up fern. Yeah. So there's actually not like, there's not really anything for ferns with the like albedo and all that stuff. So I'm probably going to have to build that stuff by hand. But this is kind of the image I'm looking for. So I have the central spine, and then I have. So basically, this is. I'm not going to get into recursion, but this is a recursive function. Like so, if we let me pull up my Epic pen. And I will be getting to the modeling stuff soon, but like this is how you kind of look at reference and break it down. So if I look at this, if we look at the shape of each individual leaf is about like that. and that shape repeats over and over again. So this shape is also that shape. So this could be level 0, level 1, and then this shape is also that shape. So it's just happening over and over and over and over again. So you could do this, like we could possibly do this with recursion. I think that's a little bit beyond beyond this stream, and I would have to do a little bit of R&D to figure this out. But we can do this by hand because we only have 3 levels. We have the 0, 1, and then level 2. So yeah, let's go and try to make one of these. The other option that we have is to use the trace node, and we can grab one of these guys and use a trace node for that. So we'll see what we'll start with the trace node because it's the fastest, but I'll see if we can put something like this together. So how do we do that? It's pretty much the same setup as our let's see, that would be in our vine leaf lib. So if we remember way back, we took this trace node and then we remeshed it and then we UV projected it, and so basically this is all of our setup, and then we throw a quick material on it. So we have this bend, and yeah. So what I'm going to do is I'm just going to copy this vine leaf lib. Right, this is the great thing about Houdini. Hey, what's up, Sonu? How you doing? Good to see you. So I'm going to copy this leaf lib. So I'm just going to hold down Alt, drag that, and I'm going to call this fern. We'll call it fern gen, just like we have tree gen. So tree gen, yeah, fern gen. So I'm going to go all the way back up to the top to our little trace node here, and I'm going to hide my other objects. So I want to focus just on this. So my trace node, I'm feeding it this leaves IV alpha. Now, I did previously go and grab an alpha and an image of that fern leaf. So if I go to, let me find that. Central projects, stream, foliage. Okay, let's see. That was branch. Here we go. So branches 30. So this is my color, and that's my alpha channel. And then this is, oh, there's my reference. Okay. So that was going to be branches. Yeah, this was branches 30_3. So let's go ahead and do that. Let's grab that. Branches. Let's not show sequences. There we go. Awesome. So if I do, let's do a remesh. It's pretty good. Now the problem with this method is like I'm making a lot of points, like a lot of points. So this is making a lot of polygons, and generally that's the trade-off that you have with computer graphics. Like if something's very quick and very dirty, it's usually really inefficient. Things that take a little bit more handcrafting, a little bit more, subtlety and what's the word I'm looking for? Subtlety or, efficiency, they take a little bit more time. So this is the quick and dirty way. Maybe we'll get into the very efficient, slick Houdini-esque way. But this is pretty okay. So actually, let's do file. So it's a pretty black and white image. So I don't really need much threshold. Now, I think what I am going to do is, because this is so complex, I'm going to make this quite jagged. Because these things are going to be pretty small. And there's a lot of them. So I want to save as much time as much as I can. All right, so I'm going to project that UV. That gives me my UV data, UV quick shade. Now I'm going to go and point this to this guy. So it should give me... turn off my wireframe. should give it my fern. Feels a little washed. Let's try and go grab the other one. No. It's feeling a little bit washed out. Let's turn on lighting back to headlight. Yeah. Oh, okay. So that's what was doing it. It was the my environment light was washing this out. So looks like this doesn't quite line up. Let me go back. Let's bring this back down. Yeah, it kind of lines up, but it's not perfect. But like I said, there's going to be a lot of these things that I really just need the color. Like I said, this is quick and dirty, because we're going to see it more like this than anything. So I think at that point it should hold up okay. So not everything, I'm very quickly learning, not everything has to be absolutely perfect. Okay, so at this point, this is where things are going to change. So let's just get rid of all this. And we'll start from here. So next thing I want to do is, let's see, this thing is quite large. This is a big fern leaf. I want this to be the correct size overall. So what I'm going to do is I'm going to drop a Tommy in here, because Tommy is about the size of a regular person. So actually, no, that's okay. Yeah, it's not bad, because Tommy is, if we look, he's about, he seems to be just under 2 meters tall. So that's about right. Like, this would be a pretty big fern. So it would be a fern that comes up to about your waist. But when it's bent over, it'll be about to your calf or your knee. So that should be... this is just a personal project, Sonny. The techniques I'm using are mostly geared toward visual effects. So feature film, so think visual effects or feature animation. But, you know, some of these Tommy is, I mean, which weird, like I'm about as tall as Tommy is. I'm pretty tall. I'm about 100 and probably about 178 centimeters. So he's normal to me. Okay. So yeah, so that's about right. So I always try to model stuff in real world size as much as I can. Okay. So I want to set this thing on the ground. So I'm going to use a match size for that. I abuse this node way too much. I use it for way too many things. It's made me very, very lazy, but I'm glad they put it in there. So I want to justify why. I want that to be min, so that it just sits on the ground like that. Cool. All right. Next thing I want to do is, let's go back to my perspective view. So I want to put a little bend on this bad boy. So I'm going to say bend. And I'm going to press enter so I can see the gizmo for this. And I'm going to press G. So that gives me my extra gizmo. So I'm going to hold down control. I'm going to snap this upwards. And I'm going to pull this guy down. Now I may have to rotate this guy out a little bit. And actually, you know what? I don't want to do that first. I want to bend this guy this way first, and then down. So I need 2 bends. So I'm going to hold down control again. And let's go this way. And I'll bring this guy down like so. And I just want to bend this guy in half. Just like that. A little bit. So I want to say deform in both directions. So it gives me the bend in both directions. So maybe that's a little bit much. It's feeling pretty good. I'm going to do another bend. Same deal. G, control. And then I'm going to bend this guy this way. And do I want to reverse this? I do want to reverse this. And I think what I'll also do is, I think I'm gonna put some noise on this as well, just so it's not perfectly rounded the entire time. So I don't know if I want to put that noise before or after my bends. Let's see, putting it after. So attribute noise. So it's going to try to color everything. I don't want color, I want position. So that probably sent him all off crazy. I don't want that to be positive. I want it to be zero centered. And my amplitude is way too high. Also, my element size is way too big. So there we go. So small element size, small amplitude, just enough to give it some character. So I just want to basically, I'm just trying to break up that silhouette a little bit. Mr. Sato says, when doing a personal project, do you like to work more with artificial lights or more reality, or it depends? It mostly depends. It depends on what I'm trying to make. So in this case, I'm trying to make something that's pseudo-realistic while kind of going over a bunch of Houdini stuff. So I'll probably try to use naturalistic lighting in this project. I'll probably eventually find an HDRI or make an HDRI. I might go over how you can make HDRIs in Substance Designer. But this is a modeling stream, so I try to keep it mostly modeling. So this is all procedural modeling. Okay. All right. So there is that. So I have my singular fern. Let's see what that looks like. And just to test this, no, I'll go ahead and do a copy. I'll do a copy. So if I go back and I look at my ferns, so they're basically a bunch of these small things kind of scattered around a circle. And I think I've done this. I think I did this before on another stream, but I'll do it again because it's worth doing. So there's basically just like a ground stalk, and everything kind of sprouts out of that. So to do that, I'm going to use my copy to points. So, and the other thing is I want this thing to be pointing down the z-axis, but I'll deal with that in a minute. Okay, so to do that, I'm going to make a circle, and I'm going to scatter points on that circle, and then I'm going to copy my fern bits onto those points. So I'm going to say circle. Plane, and I'll bring this down. Something like that. And I'll put a scatter on here, maybe a little bit bigger. So I'm going to scatter that. So it's way too many points. I probably only want, I like to work in powers of, or multiples of 8, so 16 I think will work quite well. Okay, so if I go ahead and just scatter these, and I copy these, so if I copy, tab, copy to points, we get something like this, right? They're all copied, they're all facing exactly the same way. So I need to tell these things how to rotate themselves. So there's a bunch of different ways I can do this. I could do a, let's see. So I'm gonna build this myself because I like building stuff all on my own. So the first thing I need to know is I want them all to face, and actually I can turn off Tommy now because, so I want all my ferns to face away from this center point, right? So what I can do, and I'm almost positive I've gone over this before, but these things bear repetition. So the position of each one of these guys actually points away. So there's that position, there's that position, there's that position, there's is that position, and so on and so forth. Now, if you remember way back to high school math, a vector can be represented from the origin, or it can be represented from the point. So this guy can be represented like that, right? So that gives me my direction. So that gives me 1, and then my up direction is just straight up in the air. It's just always going to be straight up in y. So what I can do is I'm going to build that. So this will be in this way, and this will be up that way. Okay. So I think I will do these. I'll do it in a attribute vault, because I usually do it in a point wrangle, but that tends to scare people. People seem to be much more comfortable with attribute vaults and wiring stuff together. So let's do that. So, and I can probably even do like everything in here, like my P scale as well. But for now, let's just work on our orientation. I don't know why I couldn't think of that word. So I'm gonna do a attribute vault. I'm gonna plug this in, and actually I want to view this guy so I can see my results of what I'm doing overall. So I'm gonna pop in here, and so the first thing I need is I need to set my normal. So I'm gonna set my normal based on my position. So I'm gonna take my position, and if I just plug that into normal, I should get something like that. So we're almost already there, like one connection, bam. Okay, so they're all flowing out like that. I might not even need an up vector, but just for the sake of complacency, I'm gonna make an up vector. So I'm gonna drop in a constant. This constant is gonna face straight up in the air. So 1. And I'll just take this and bind export, was basically bind export makes an attribute. And actually, let me turn on my attribute spreadsheet just so we can see what's going on here. So I have this in here, which is what I connected here. So if I disconnect that, no in. Now if I take P and I plug it into in, there's that. Now in general, we want our normal data to be normalized, right? Because those P's are going to be all different lengths. Those little arrows are going to be all different lengths. So I want to normalize this beforehand. So I'm going to say normalize. Drop that in. Now you won't see any change, but just the inner mathematician in me makes me feel good. Okay, so next thing I'm going to do is I'm going to do a bind export. This is going to be my up. So now I have my up. Awesome. So that pretty much builds my, let's make sure that's all working correctly. Yeah, so that pretty much builds my the fanning aspect of it. Now, I also want from the center, I want my fern bits that are in the center to be bigger than my fern bits that are on the sides. Okay, so that's going to be P scale. So I think I can do all this in here. So I can also do, let's see, I don't want to do this. I think I'm going to do this outside because I want to get the maximum value. Yeah, I want to get the max and min distance. So actually what I'll do is I will take, so if I have points that are like this, this is my origin. So I want to get the distance between 0, 0, 0 and at P. Okay, so with that, so for that, I can make a distance attribute. So I'm going to take and drop down a length vector, or a length attribute. So what this thing does is I can give it P, and it'll give me the length of P. So it'll basically give me the distance from the origin to that point. Okay, so I'll bind export this as well. and I'll export this as dist. It's going to be a float, and we'll plug that into there. So now I should have dist. So the closest points are looks like 0.4, and the highest is, oh no, the largest is 0.4, and the highest is 0.009. Okay, so I could hard code this stuff in into a normalization, but what if I change the size of my little disk? Those numbers are going to become invalid. So I'm going to do some trickery. So I'm basically going to normalize this outside of the point blob. So this is going to be, this is in, up, and dist generation. I always like to label my attribute VOPs because they can do so much stuff. It's sometimes hard, and I usually color them like either green or yellow. Actually, let's do pink. Because they can do a bunch of different stuff, so it's very hard to tell what they're doing at any one time. So I usually like these are like one of the few nodes that I actually name. So my attribute VOPs, volume VOPs, point wrangles, edits, anything where it's like ambiguous as to what that thing is doing, I usually name the node. Okay. So what I can do now, so I have this distance. So what I'm going to do is I want to get the maximum and the minimum distance, and then I want to normalize that information. So what I can do is I'm going to take a attribute promote. So I'm going to take my distance, and I'm going to promote that from point to detail. Now by default, this was going to average all those values, but for this, I want it to be, give me the maximum, the highest value. I'm going to change this name, and I'll call this max dist. Okay. So I have this max dist, and I'm going to do this again. And I'm going to call this min dist. So if I look at this guy, should see. I don't want to delete my original on either one of these, actually. So I have my max dist and I have my min dist. So now what I can do is I can normalize that data, right? So so what I'll do is I'm going to take both of these and push them back down onto my point. So all my points will just get the same max and min distance. Actually, I could also do a detail. Import detail attribute. Oh yeah, I can do import detail attribute. Great. So I'm going to do that in another attribute VOP down here. So like I said, I usually do most of my stuff with typey cody, but you know, there's so many ways to skin cats. This is a horrible term. It's a horrible term. Ways to skin cats. There's almost always a VOP equivalent to Vex. So I'm trying to get better at VOPs. Trying not to type so much. Trying to do more node-based stuff. So yeah. So I'm going to make another attribute. Attribute VOP. Let's plug this in. I'll plug this in here. So in here, what I'm going to do is I'm going to grab that import distance. So let's say that. So what I'm doing, and what I want to do is I want to normalize this data. So let's say, for example, that my maximum distance is, let's say 2. Okay, that's my maximum distance from the origin. So from here to here is 2. So what I want to do is I want to normalize this. So I'm going to take my current dist, which is distance, and I'm going to divide that by my max. Okay, so if this guy is divided by my max, which is 2 over 2, it'll be 1. If this guy, let's say this guy is 1, and if I take 1 over 2, that'll be 0.5, so that'll be half. Right? So that's called normalization. You can go a really, really long way in computer graphics with just really, really simple mathematics. I think that's one of the biggest things that like my students ask me. It's like, oh, what should I learn? What software should I learn? I was like, learn math, because math is the underpinnings of all this stuff. And if you don't know how these really simple kind of ideas of like normalization and vectors and rotation, stuff that seems really, really boring, you can't do these higher order modeling techniques. And this is the type of stuff that really makes you marketable. And this is the reason why I do these things, because there's not a lot online about this. Like everything is, ZBrush and Maya and Substance Painter and all this stuff. Those things are great, and I love them, and I think they're awesome. I love working in them. It's so much fun. But if you want to make lots of money, like if you want to make yourself very, very employable, and I say this almost every other stream. One of the best pieces of economic advice I got when I was in middle school from my middle school economics teacher. He said, if you want to make money in this world, you can do it one of two ways. You can do things no one else wants to do, or no one else can do. So if you know this type of stuff, you're doing both, because it's hard. It's really difficult. Okay, so if I look now, I have this. Let's see. I have my distance function, so I'm going to grab that. So I'm going to do a bind import, or just a bind. Grab that. Say dist. Okay. And if I plug this into, like, if we look at my point numbers, so let's see, 8 is the closest, I think, 8. So if I just plug this dist into P, it should line them up. Let me make sure I'm viewing that. There we go. So it just lines them up by distance. So 8 was the closest, then 1, then 12, then 5. So if I cut that away. So 8 is the closest, then 1, then 12. So it's moving out, then where's 5? Should be somewhere around here, then 5. Okay, so that's sorting the distance. Now, to get these detail attributes, this max dist, I need to do something a little bit tricky, what I was just testing before. So I'm going to type in detail. So import detail attribute. So I want to grab that attribute. So this file is very confusing. Most people think, oh wait, I need to grab this file from somewhere. You don't. The file can be replaced with any of these op inputs. So this op input 1. And you can see that goes away. So what I want to grab is max dist. And that is a float. So if I put max dist, and if I just plug that into my P, I should get just 1 point here, okay? And that should be 0.04 up, okay? So to get my normalized distance, I take, so if we remember that equation, like this is my current over my maximum. So I'm just going to do a divide. So I take my current distance over my maximum distance. And if I plug this, let's just plug this in a color. And I'll make this dark. I'll make it gray. So we can see now the ones that are closest to the center. So this 8 is really, really dark. This 8 is really dark. And as we move out, we're getting brighter and brighter and brighter and brighter. Okay? So this is not what I want. Well, Yeah, I could use this. Okay, so that's just for visualization. So now I want to drive P scale with this guy, right? So I'm gonna plug that into a ramp parameter. So I'm gonna say ramp parameter. So this will allow me to control this outside of the input. So this is just a singular color. So I want spline ramp. And I'm going to export this out to P scale. Tab bind export. This is going to be P scale. I'll plug my ramp into P scale. So P scale is an attribute that Houdini knows about and it's looking for, and it says, oh, if you have this P scale and you copy stuff onto me, I'm going to use my P scale to drive that value. So if I go back out to my fern and I look at this guy, so let's go back to my points. There's something going on here. Why am I not getting a P scale? Oh, because I need to do a bind export, not a bind. Bind. Talking and typing, it's very difficult. P scale. Okay, and the weird thing about Houdini is it always makes this ramp completely flat when you first build it. So we'll do that. There we go. So it also looks like my fern is facing the wrong way. So let's go back and let's scatter this. Let's down to, let's say 2. Yeah, I feel like my fern, it should be facing out that way. So no problem. I can take, so if I do that, I might just, so I can either correct it over here, or I can correct it over here. I think I'm going to correct it over here because I like my normals facing the way that they're facing. So I'm just going to do a transform. And we'll just take this bad boy and rotate it 180 degrees. So now that should be pointing out. Let's check. Let's bring this guy up because that's a P scale of 0. Yeah, cool. So let's bring this count up back to 16. So I like that number. Cool. So just like that, like we've built out this thing. Now I have a lot of intersections, and all of my bins are pretty much exactly the same. And this is backwards, right? I want my big, do I want my big ones? I want my big ones in the middle and my little ones on the outside. So let's check and make sure that works. Let's color this as well. P scale. Let's see. Yeah, those little ones on the outside are, yeah, that's fine. That's fine. Yeah, I want little ones on the outside and big ones on the inside. Cool. All right. So that's one way of doing this, and I can pack all this stuff together. But I want to take this one step further, and what I want to do is I want to vary this second bend, or no, the second bend. I want to vary each one of these. I want the ones that are in the middle to be less bent, and the ones that are on the edge to be more bent. So I can still probably use that that P scale data. So let's see. Yeah, so I'll use this. I'm gonna come in here. I'm gonna call this. I'm gonna rename this ramp. I'm gonna rename this to P scale. Scale ramp. And it doesn't have to be linear. I can make it like kind of like fall off quickly as it gets to the edge. I'll make these ones. I want to make them big enough to be worth the calories. Okay, so what I think what I'm going to do is I'm going to take away this noise and I'm going to move it actually up. Yeah, that doesn't really matter. So I have this first bend and the second bend, and let's see. Let's transform. Okay, so I have this first bend, the second bend, and that transform. So this should be facing in the Z direction. Okay, so I want to bend these so that I don't have to use this transform. So that was there. So let's see. You bend this way. And then, actually, this is what I'll do. I'll take this transform, put it way up here, just after my match size. First bend. So this first bend should go the opposite direction, because I want to bend it along Z. Like that, and then this guy here should go the other way. And it'll become apparent why I'm making this small change, because I want the last thing that's done to be this guy. Good. Perfect. Okay, so now I want to vary. I want to vary this bend per copy. And furthermore, I want the ferns on the fronds in the center to be kind of up like this, and I want the fronds near the edge to be pushed down a little bit, because I feel like things grow up and then gravity takes over and it pulls them down. So as they're growing and they're really small, they're still kind of straight up and down. Like gravity hasn't had a chance to grab them and drag them back down to the ground yet. Wow, we're already an hour through. You can see how fast this stuff goes when you get started to go on. So to do that, a lot of tutorials you'll see online will use an older method called stamping. I tend to try to not use stamping ever since I learned this technique. It's from a guy named Jeff Wagner. He's like been with SideFx forever. They call him Jeff Old School Wagner. He did a webinar, I think in 2016 or something like that, like 4 or 5 years ago, about the new kind of way they're handling geometry. They're trying to get rid of the stamp node because it's incredibly inefficient. So when you stamp something, you have all this data coming in, and then it hits your copy to points, and then it runs all the way back up here, and then it has to run all the way back down. And it has to do that for every single point. Now, in this case, well, I'm only doing this for 16 points, that's fine. But what if I was doing this for 1 million points, 10 million points, 3 million points? That's not out of the realm of possibility when you're doing this type of work. So they came up with this thing called a loop. So I can do whatever I want inside of that loop, and it'll stay contained. It's not going to keep running all the way up to here. So to do that, I'm going to say it's going to be called for each point. So this is going to run through each point and do whatever's inside of these brackets. So I'm going to take that and plug that into there, and I'm going to plug firstly the output of that, and then I'm going to plug in that. So I get roughly the same idea here. But what this allows me to do is it allows me to do like the single pass. So I can look at what each one of these things is doing. So because I can operate independently on each point, I can do something different to each point. So along with my P scale, I'm going to do a bend scale here. So along with that, I'm going to do a bend scale. So this is my normalized value here, so I'm going to call that norm dist. Normalized distance. So that goes out to my P scale. And so I'm also going to bring this out into a ramp parameter. And this is going to be also a spline, and I'm going to call this bend amount, bend ramp. Okay, so that's going to go out there. Export. So I might have to do this with expressions. I try to do as much stuff as I want, as much stuff as I can with attributes, but I might have to do this with expressions. But it's always good to have. So I'm going to call this bend bind export. Bind export. And we'll call this bend. Not band, bend. And once again, I'm just experimenting here. The other thing that I want to do is I want to have a maximum and minimum bend, because right now this ramp is only going to go between 0 and 1. So I'm going to put a fit in here. Fit range. Let's do fit range unclamped, because I want to go above or below 1. So my 0 to 1 will become whatever this destination min and destination max are. So I want the user to control those. So I'm going to say middle click and say promote parameter, and promote parameter. And that's just a convenience function to make these little parameter nodes here. So I'm going to call this this is bend min. And this will be bend max. Okay. So don't know if I'm going to need this, but it's always good to have. So if we look now here, we grab this guy. I should have bend. Yeah, so we have this value bend here. So I want not a lot of bend in the center, a lot of bend at the end. Cool. Or no, wait. Yeah. Bend. Yeah, that should work. We should be able to see that. Okay, so yeah, so I need to figure out what iteration I'm on. Like, which one of these am I on? So basically I can say boop, 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 boop. Right? Yeah, so let's see. I don't want to do this. Can I sort these? I don't want to do this. All right, let's just work our way through. So I'm gonna say create meta import node. Bam. So what that does is it makes this extra node, and it has some detail attributes on it. It has my current iteration and my oh, that's how I'll do it. Great. So I have my current iteration and I have my number of iterations, right? So because I have this current iteration, right? So my 0 point coming in. So this is a little confusing. Let's turn this on. So 0, it'll go through, will be my iteration, right? So if I do at this iteration of 0, it will be this point, and that point has a bend value attached to it, which I created here. I can then use that to drive my bend value here. So this is a little convoluted, but we'll see if it works. We'll see if it works, because if I go to here and I go to, let's see, so that's point number 2. I should be on iteration number 2. Okay. So I need to bring this dude into the fold, I believe. So I'm going to make another create meta import node. So I can make as many of these as I want. With this one, I'm going to say, not fetch metadata, I'm going to say fetch input. And I'm going to take this guy and plug it right in between those two. So this brings this guy into this little orange kingdom. Because if he's not inside that orange kingdom, I can't really do anything with him. Like the loop doesn't understand anything outside of that. Okay, now let's try to do some madness and see what we can come up with. Okay. So what I want to do is I want to look at this bin value. So my bin value is going to be, if I do 0, okay, that's going to be 0. And then the maximum bin I want, let's say, is going to be maybe negative 100. Just to make it easy. So up here, my destination minimum should be 0. My destination max, let's see, let's make sure. Actually, I'm going to rename those as well, just so it's easier to read. So this is my min, so we're going to call this, label's going to be bin, minimum bin, min binned, and this one's going to be max binned. Keep that consistent. Camel case those. Okay. Max bin, let's put this at 100. Min bin is, let's say, 10. Okay. So the minimum it'll bin is 10, maximum is going to be 100. And that's also controlled by, so down here is now 10, and up here is now 100. Okay. So what I need to do is I need to write a little expression here that is going to fetch my current iteration from this guy, and then it will find the binned value on that particular point of my incoming for each, I believe, and then apply that to this guy here. Okay, so let's that's a tall order. Let's see if we can get it to work. Okay. Here we go. All right. Gotta psych myself up for this stuff because sometimes it doesn't work. But that's learning. That's not everything you try the first time works. Sometimes you have to go, and if all else fails, I can just go back to the copy stamp kind of slower method of doing things. But I always try to work as updated as I can. So let's write this expression. So the first thing I want to get is this detail attribute. So I'm going to say detail colon. So this should return me. It says returns the value of a detail attribute. So detail, surface node, attribute name, attribute index. Okay. So detail, surface node. Oh, it's giving me the absolute value. Let's not do that. Detail, surface node should be ... for each begin, I think that's going to be metadata 1. The attribute, which is iterations, see if I spelled that right, and then index is going to be 0. Let's see. Iteration. Oops. Oh, no. It's iteration. 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 No, S. Now let's see. What are you yelling about? Expression. Detail. Iteration. Let's look at the caption again. detail. String, string, float. So again, should be // for each metadata 1, comma, iteration, comma, 0. Yeah, there we go. So if we look at this, so right now it's at 0. If I turn off single pass, I should get some, like some are bent and some are not, right? But they're all going between 0 and 1, right? Or 0 and like whatever iteration they're on, so 12. So if I take, let's just try real quick. Let's just times 100. So this tells me that this is always coming out 0. Let's see if I spelled that right. ITERATION. TION. Yeah, there we go. So now they're all spawning with going between 0. So it's a 100. So the last one, so this one is number 1. So that's only getting about 100 degrees. And then they're slowly getting more and more and more and more bent. Now that's not what I want. I want to fetch the bend value from a point. So this is this is actually my point number. And so I'm going to make this a little bit longer. So I can do Alt, I think it's Alt E to give me a bigger, yeah, this is my bigger expression editor here. Because this is going to be kind of long. I need to actually learn how to write multi-line expressions. I rarely ever have to do it. So that I want to do a point expression. So what the point expression does is it says returns the value of a point attribute. So I have a point attribute here. Returns the value of a point attribute. String, float, string, string. So the first string is the surface node. The second string is the second one is the point number. The third is the attribute, and the fourth is the component. So the first thing I want to do is grab the surface node. So that would be whatever my points are doing. So that for each begin. So slash for each begin 1. The second one, so that's the surface node. That's the point number, which is my detail attribute that I grabbed. The third is the attribute, so that's a string. Also, that's I put that. Did I say I call it bend? Just bend, and then the 0th element. So say apply. Yeah, there we go. So it's kind of working. We're getting different bends. I think I'm bending the wrong direction, though. So if I go up here, yeah. So max bend, this should be negative and negative. Sweet. So now, let's take my max bend, and we'll start to crank this up. Yeah. So we can see now, these ones on the bottom are bent way more than the ones on the top. And if I want my ones at the top to be a little bit more bent, I can do that. So I get like this just insane amount of control over my fern, right? Like, so now I have like these guys that are down on the side, and I can actually, so I can control this bending overall. Okay. So I think that's good enough for now. That worked out way better than I thought it was going to. Luck of the draw. Sometimes things work. So let's just clean this up real quick. Shift L, line those up. Shift L. The only thing I kind of, from an aesthetic standpoint, the only thing I really don't like about this is you kind of have like this jumble of stuff down here in the for loop that you kind of just have to like manage. Like it's got like this weird shape where everything up here is nice and kind of rectilinear. What else can we do to this? Yeah, I think that's all right. So I could add some random. Well, let's go ahead and add some randomization into our P scale, right? So I want to randomize my size on top of building this kind of organized center out. The other cool thing about this is I can grab this scatter, and if I want more ferns, if I want a lusher fern, I could do that. If I want a thinner fern, I can do that. I could also, what else could I do with this? I can change my seed, and that'll give me a bunch of different ferns. So I can package this up into a DSA and have like just like a fern node, where I can say number of leaves, my circle size. I can make it broader, like if I wanted to spread my leaves out, or if I wanted to make it tighter. I want to make that a little bit broader, so that they're kind of like that. I have to remember what the context of these things are going to be in. If I bring back Tommy, we're going to look at this, and they're going to be like all over the place. So always kind of draw back and be like, okay, how big does this thing look? Am I going to get any more kind of information out of what's going on here? And my answer for this is no. Like, I don't really think I need to do any more work to this. Okay, so the last thing I'll do for this is what do I want to do for this? I think I'm going to use I'm going to remove that UV quick shade, and I'm going to do actually I'll leave that there for diagnosis, and I'll just do a labs quick material, and I'll use and I'll just give it this like just a general kind of overarching material, because remember there's gonna be a lot of them, and then I'll pack it up so that I can save on memory, and then I'll scatter that around to whatever I need to do. So let's do that. Yeah, so I'm gonna say quick material. So that kind of overwrites my materials. I'm going to go and grab that same base color that I grabbed before. Drop that on there. So good. I don't really need an opacity texture. Actually, I'm going to go get just a flat green one. Yeah. Let's see. So roughness. I want this thing to be pretty smooth. So I'm going to bring my roughness down a bit. And my metallic is 0. That's really the only thing I'm going to deal with. Is just make it pretty smooth and green, and yeah, that should be fine. Let's see if I can, yeah. And then I'm gonna pack this and then do an output node. So I'm gonna say pack. So I get this, you get that new visualization. So that packs that in. So now I only have 1 point to represent all this stuff because it's all held in memory, and I have this path for my primitive. So I have this one primitive that's a pack primitive, and it's looking at that. And then I'll do an output node. Sweet. So now I have my fern. So I think with this fern now, let's hide my head. Look at where's my fern? Okay, that feels pretty small. Like, this head is gigantic. It's really, really big. Because if I look at my test geometry for Tommy, like, that looks about right. This head is giant. And that's what I wanted it to look like. I wanted to give it a pretty big sense of scale. Now, in doing this, you have to work on dealing with that as many these lots and lots and lots of objects. So I kind of strayed away from that a little bit. So let's bring this back down. So this grass is super tall. Like, it's about to his waist. So let's bring that grass down so that the ferns can kind of take over. So let's say, and the tall grass as well. So I want the tall grass. I think a kind of like a cattail or something like that. That's what I wanted them to look like a swamp. Comes up to about your elbow. The tallest of tall grass kind of comes up to your ankle. So let's rejig this a little bit. And then I might actually make my fern a little bit bigger, like make it come up to his knee or something like that. So my short grass, let's say, show other objects. So let's see. Modify density, scatter, orient, make p-scale. Noise. Expression. So my make p scale here. So it looks like I'm going, let's see, I'm getting my attribute noise, I'm doing a fit, I'm multiplying that. Let's see, this is my mask. Yeah, so let's bring this down. Yeah, there we go. 0.3. That's still pretty much up to his calf. Ooh, let's save this. Save as 6. What are you doing, Houdini? Oh, it's cooking. Cool. So that's. Are you still cooking? Say 0.15. Cut that in half. Still really tall. 0.05. Actually, what I'm going to do that, I'm going to put this back to 3, and I'm just going to put a giant multiplier at the end of this. That'll make it easier. So basically take everything, scoot it down. I could conversely just translate all this stuff down just directly into the ground, but that's kind of cheating. So here, so this is multiplied. Those two things get multiplied together. So let's just put another parameter. Actually, I'll just do it as a constant because I haven't really done anything else with parameters in this. p scale, so I'm going to do a constant. If I just plug this into the multiply, now its base value is 0. If I plug this into here, all my grass should disappear. Yep, there we go. So let's put this at like 0.5. So it's a lot of grass, which is why it's taking so long to cook. Let's say 0.25. Yeah, that's feeling good. So that's kind of blanketing his, like right at his ankle. Cool. Awesome. All right. So now I'm going to bring in my fern. So let's go back up to my short grass. Let's make sure, yep, that's all assembled. Yeah. And we'll go back up. Let's look at our head. Now our grass is shorter. My tall grass is like huge. Like this is like 2 of Tommy. So this is like 12 feet tall, or like 2 meters. Actually, more than 2 meters. This stuff is like 4 meters tall. So my tall grass is way too tall overall. So I believe I can say orient, scatter, noise, scale. Let's bring that scale down. There we go. Just bring that down. Let's bring our so I might be able to exaggerate this a little bit. So that one, like that's right by him, I'm trying to hit his elbow right there. Maybe a little bit taller. Okay, cool. Yeah. So there's my tall grass. So now I've kind of brought the rest of this into alignment with how big the rest of this should be. So now that everything's a little bit more sparse for my tall grass, maybe I'll give my scatter a little bump. So force total count, let's do 1500. Yeah. And maybe for my short grass, pushing this a lot, like a lot. Where's my scatter? Scatter. Let's do an extra 100,000. All right, so now that I have that worked out, now I can start to, so what I'm gonna do is I'm actually gonna, I think I'm just gonna hand paint where I want these ferns to go, because I know my camera's here somewhere. Yeah, here's my camera. I wonder if I can turn on view projection perspective. So I know my camera frustum is something like this. So I want to paint, I just want to paint those ferns in exactly where I want them to go. Like I kind of want them all up in here to like kind of like fill in this area. And sometimes hand painting is fine. Like you don't have to do everything super procedurally. I try to, probably to a fault at times, but yeah. So there's my fern gen. Okay, so let's do yeah, we'll call this let's say trees. We'll make a new geometry. We'll call this fern. And we'll pop inside here. And the first thing I need is something to grow my ferns on, which is going to be my ground. Tab, object, merge. I'm going to go get my ground. ground. I'm going to hide my other objects for now. Hide other objects. And the first thing I think I want to do is... Actually, you know what? I could do this procedurally. So... No, I'll do it by hand. I'm thinking about. I was like, oh, I could just scatter ferns wherever this stuff is dark or light or something like that. We could try that. Let's try that. Scatter. We'll say density, and we'll say CD. Doesn't really give me much. Okay. So what I'm going to do is I'm just going to do an attribute paint. Attribute a paint. Plug this into here, and what I want to paint by default, this says I'm painting mask. I want to paint density. So now if I go back to this guy, I should have so I'm gonna press enter, and I'm gonna bring back my other objects. And so what I can do is now I can start painting in where I want my ferns to be. So I need to make this quite large, maybe not that large. So I want to paint in maybe a patch here, a patch there. So this is making a lot of points, because it's concentrating them all. So let's bring our density down a little bit. Looks like small clusters of ferns around this guy, in between these. And so this is kind of like pseudo procedural modeling, because I can always go back and change this. This painting. Okay. All right, so if I go and I look at my, let's bring this up. So I do want a fair amount of ferns in here. So let's do 400. So I have these 400, and if the 400 is like spread across all of these clumps. Okay, so now, so that's my kind of like my copy to points. So now I'm going to bring in that fern. So object merge. I'm going to go get my fern. Where are you? Are you there? Oh wait, I can't. That was I'm bringing my own. I'm bringing myself. So I don't want fern. I want fern gen. Fern gen. Where is it? Fern gen. Cool. So let's just see what this looks like. I'm gonna grab this fern gen. I'm gonna say copy to points. Here, this guy's going to go in there. And now we get all of these fern objects. Now, I think they're picking up some of that color from yeah, they're picking up that ground color. So to get rid of that, I'll just come back to my ground, and I will say attribute delete. And we'll say point attributes, say CD and dirt. So now I get my bright, vibrant green ferns back. Okay, so right now they're looking very, very uniform overall. And on my scatter, I think I'm going to turn down my relax iterations. So I kind of want them, yeah, there we go. So my relax iterations are trying to push everything away from each other. But I don't want that. Like ferns tend to like cluster together. So I might need just kind of like smaller patches. The other thing that I can do is, let's see if I can just output my P scale. Yeah, oh yeah, there we go. That's nice. That's very nice. So my scatter is kind of taking care of all that stuff for me. It's taking care of my P scale value. So what I can do now is I can go back to my attribute paint. And so what I'm going to do is I'm going to make, let's say erase. I'm going to make these little islands a little bit smaller overall. Cut this one in half. Because I want them to be really bunched together. I want their density to be pretty tight. So I'll make a couple more islands, or I'll like cut these bigger islands in half. So I'll just kind of put, let's put like these little kind of clumps. So I can really art direct where this stuff goes and how it looks overall. Now this thing's huge. Okay, cool. I like that. I like where that's going. So I think I'm gonna do the same thing as I did with some of my other things. If I look here, I should have a P scale attribute, and my max P scale is 5 something, and my min P scale is 0.07 something. So I'm gonna do the same thing with my P scale. So I want, because I know I like the distribution of these, but like maybe I don't want this thing to be as big, and maybe I don't want these things to be so small. But I mean, I actually kind of, let's look at this in context. Actually, let me look at it from the camera. Yeah, so I'm gonna go back to my attribute paint and middle mouse. I'm gonna actually erase this stuff, so I'm getting more density overall. The side of my camera frustum. So this is a very visual effects kind of thing. Like you probably wouldn't do this you probably wouldn't paint to the camera like you would with visual effects. So paint foreground. Come on. For some reason my paint isn't working anymore. So I can't. Okay, that's fine. Yeah, so let's look through the camera again. Show cam. Yeah, I'm liking that. Overall, I think they're pretty good. They're feeling pretty good. I would like some more right here. I don't know why my paint isn't working though. just kind of crapped out on me. Anyways, so yeah, that's good. And so if I want more of these, I can always say, give me some more. Now I'm starting to hit my limit. So it's starting to render those as boxes, but it's been pretty good. So it's rendering those really small ones as boxes because I have a size a poly count limit. So let's on these guys. I don't need to pack an instance because they're already instances. So let's go and let's look at our render view and see what we get. Oh, also the other thing that I'm seeing is I can't believe I forgot about this. They're all rotated exactly the same way. So our brains are built to pick up repetition. So changing the position, size, and scale, even though it's the same kind of randomish object, will fool you into thinking that they're all unique. Because technically they are, right? If something is a different position, size, and scale, it is technically unique. So just waiting on this to build, see what it looks like. Any day now mantra. I'm gonna stop this and I'm just gonna reset the whole thing, let it run again. It's weird. Why are you not? Ah, there we go. Okay. So for some reason my control, there we go. I was rendering like this tiny little window over the corner there. Yeah, so I'm getting like my little ground ferns here. Hey, Rushback99, how you doing? How are you today? Yeah, so I'm getting my ground ferns here. So I think I kind of want them maybe everywhere. So I think I'll just add to my density overall. Yeah. So I'll just add to my density to give me more ferns, more places. Yeah, I'm pretty. If you can't really tell, I'm usually a little bit more higher energy in my podcast. I'm moving, so I've been running around Hong Kong all day, looking at God, I can't even talk. I'm so tired. I've been looking at flats all day, so it's been interesting. It's been an interesting day. Okay, so I like where this is going. I kind of like these really big ones, but I still don't want to get it too big. Like this is huge. Like this fern is like almost the size of Tommy, so I don't want to get too overzealous with this. But I think I do want some more. I want some more ferns just overall, because I'm kind of replacing my grass with the ferns, and my grass is now a little bit too fat because I made it smaller. So let's work on that. So my ferns. So if I've painted in this density, what I'll do is I'm just going to do an attribute expression, and I'm going to take the current density I have. So it's going to be custom float density, and I'm going to say self plus value. So if I look at my ground here, and I visualize density, if I start to bump this guy up, it'll give me just a little bit more density everywhere. So now when I go to my, so now I have kind of ferns a little bit everywhere. Okay, so now what I can do is I'm going to create my my random rotation, right? Because if we look at these, like, we can see this guy is always pointing that way. So that's like repetition. We can tell that that all these guys are pointing exactly the same way. Maybe this should be 5. Yeah, there we go. So I still want to see these clumps, right? But, and actually what I want to do is my P scale. Yeah, I do want to do that P scale, because of the ones in the clumps I want to be a bit bigger, and the ones a little bit further away I want to be smaller. So this is giving me a nice initial P scale, but I want to edit it overall. So I want these guys to be big, because, like, if something is growing in like a cluster, it means there's like more nutrient there. So everything kind of gathers at that spot and it gets really healthy and really big. Everywhere else there's not a lot of nutrients, so it can only support so much, vegetation in those spots. That's my story. I'm sticking to it. All right. So first, let's work on let's do that P scale first before we do that. So so it's going to be after my scatter, because my scatter is what's generating that P scale. So I'm going to do the same thing as I did with in the fern generation. So I'll make my max, and then I'll normalize that, and then I can control how big these guys are and how big those guys are. I can always multiply a value over that to give me even more variation. Sweet. Okay. So let's do that. So let's do attribute promote, and this is going to be, I don't want to delete my original. I want to say P scale, and I want to do that as maximum, and I'm going to say change the new name, and I'm going to say max scale. Well, max P scale. P scale, max P scale. So here, I should see, I want point to detail, max P scale. So my max P scale is 2.41 whatever. Okay, so I'm gonna go into my attribute block, and you can see, like, once you learn like one of these principles, you can use it for so much stuff. So I'm gonna say mod P scale. Okay, so here, I'm gonna do that same detail, import detail attribute from op input 1, and that's gonna be max P scale. And then I'm gonna do a bind import. Grab my P scale, divide these two, P scale, max P scale, and I'll run that into a ramp parameter. spline, and then bind export back out to p-scale. Should all those disappear because the ramp comes in flat. So let's see what we get. Yeah. So now my biggest p-scale, my biggest ones are clumped together, and then I get like these little ones in here. And then I can do the same thing. I can run that through a fit unclamped to say what's my biggest value and what's my smallest value. So tab fit. So 0 to 1. So destination min. So let's say 1, and let's say 4. Ooh. That's a little bit too much. Say 3 and 0.5. Yeah, so I got these big ones that are all clumped together. Right, and then what I can do is, yeah, so I'll do that mod p-scale, and then just to add a little bit more variation, I will multiply in a noise over this. So I'm going to say attribute noise. This will be not CD, p-scale. So that's going to be add. I want to do multiply. I'm doing this as I'm looking at like Tommy, so I want, it's gonna be kind of big. Cool. So now I got these big ones that are all kind of clumped together, which I can control with this paint, and I have some smaller ones that are just kind of hanging out in there. Those are a little bit smaller, like little itty bitty baby ones. Okay, so that's my p-scale. So once again, but still they're all same. They're all rotated the same. So I'm going to make a orient attribute, also with an attribute vol. Yep. So let's do that. So I'm going to do another attribute vol, and I could have probably figured out a way to do all these in one vol, but it's always good to be compartmentalized. So this is generate orient. Right. So what I'm going to do is so an orient consists of, remember, it's a quaternion, so it's a vector and a rotation around that vector in radians. Okay. So to make this, I just need, I know my vector never, my up vector never changes. It's always going to be just 0, 1, 0. So I'm going to say constant. This is going to be a vector 0, 1, 0. And then I need my angle. Now I want my angle to be based on my point number. So I just want like a random angle. So that's PT num. So I'm going to say rand. Plug my point number in the rand. Now I want this point number goes between 0 and 1. So I want to remap that 0 to 1 to 0 to 360. So tab, that's going to be a fit range. So 0 to 1 goes to 0, 2, 3, 60. Now this is degrees, right? So I need to convert my degrees into radians. So I'm going to say radians, degrees to radians. I'll plug that in. And so now I can construct a quaternion out of these two values. So I have my vector, and I have my random rotation between 0 and 360 degrees. So I'm going to say quaternion. So my angle is going to be, this is my angle, this is my axis, and I'm going to spit this out as an orient. So find export. This should be a vector 4. Where is it? Float. 2, 3. Four floats. Yeah, 4 floats. No, it's a matrix 4. Override type with input. I'll probably just plug that into there. Yeah. So it'll just override it. So it doesn't really matter what I put here. It's just going to override that. So I can call orient. Caps lock's on. Orient. You should see all these guys now. As soon as I do that, now they're all rotated in different directions. So if I turn this off, they go back. I turn that on. So now they're all rotated in different directions. So if I start to bring this down, let's say 180, right? So now they can turn 180. But I want them to be able to turn all the way around, so 360. So now they have unique positions, they have unique scales, and they also have unique rotations. Pretty sweet. All right, let's go back out and see what that looks like in a render, and that should take us to the end of our stream. There we go. So having that little man in there, having that little Tommy really gives this a sense of scale. So I don't think I'll get to it in this, but I may, maybe offline if I keep working on this, like maybe have a guy like standing there with like a torch or something, like maybe like cast it like he's like an explorer and he just found this crazy like broken head with these like kind of scary like standing stones. You don't really know what it's for. You don't know how long it's been there. Yeah, that's much better. That feels pretty good. These might be a little bit too big now. These are like Jurassic ferns. Oh, it's okay. You can always watch it. We always record these. You can always watch them back on YouTube if you feel the need to. Actually, no. I think I like those really big. Maybe they're a little bit too big. I don't know. This is where an art director helps, right? To have somebody to answer to be like, make it look like this, and you're like, okay. But yeah, I'm digging this. I'm digging where this is going so far. Yeah, these are definitely too big. And I might need to up the density overall. Because I'm getting kind of like these bare patches now. I might go and paint in some more chunks for the leaves. Half resolution. So this will take a little bit to resolve, but we're getting there. We're getting there. So I will leave this at that. I'll do an offline render, see where this is at. I may build some more some other types of vegetation offline and fill this in, but it's basically the same thing over and over again. You figure out how to make some vegetation, you figure out where you want it to go, you figure out how big it is to be, you randomly spin it, you randomly scale it, and then that's how you get like these very naturalistic looking things. So I have 3 types of vegetation. I have my ferns, I have my grass, I have my tall grass, And then maybe I'll just throw in something like these guys here. That's easy enough. It's just like one stalk with some leaves scattered around it. Okay, so that is our stream for today. Thank you, all of you that came and participated, all of you that came and watched. You have no idea how much it means to me. Have a good week. Have a good weekend. Remember, drink water, eat your vegetables, wash your hands. Be safe, and I will see you next week. For all your CG modeling needs, go to cgspectrum.com/3D-modeling. I'm Bryan Bentley. You guys are awesome. I'll see you next week. All right, bye.